Hey, happy Wednesday, guys. Sorry that I'm getting this out a little bit late. And this is actually a summary video of the last 2 days of what we've been working on in class. We finished with percents. Of course, it's going to come back and haunt you. But we've finished talking about percents a lot in class, and we've moved on to the Architects project, which is a 2.5 week project that you are going to be working on with your teams. So, in this project, as we've discussed, you are going to be designing a building for a firm, your client. And your client has a few specific needs, some criteria. They want a building that's going to be all glass walls. And we talked about some of the reasons why glass might be better for buildings. Maybe it's energy efficient. Maybe it has this aesthetic appearances. It looks nice. It looks interesting. It gives people a good view. If you're claustrophobic, it's nice to have a little bit more space to look out the window, things like that. So our walls need to be glassed. We also need to have a space on the roof for a garden. So this roof is going to be all usable space. You need to be able to use it for that garden situation. Those are our big criteria. Our constraints. Our building has to be 20 units tall. So for all of the scale models that you'll be making, you'll be able to model that by using grid paper and having your 20 units show. We also need the garden to have a perimeter of 36 units. So that means if you go around the garden, it's 36 units around. That's it. Those are our criteria and our constraints for the building. So over the next 2 weeks with your team, you're going to reason about these solid figures. How does area come into play with this? How does volume come into play with this? And think about how you could design the very best building for your client. 3 things to consider. Cost. So if we have a building that has a lot of glass, glass is expensive, so we need to think about cost of the glass for these walls. Think about the area that these walls are going to take up for glass. Also, usable space. What is the area of this garden on top of the building going to be for your client? And then efficiency. Does this building have a lot of space inside of it? Usable space means more office space for your client. They want you to have a larger volume in your building if possible. So those 3 things are going to guide you as you are considering the building that you will end up proposing to your client. So on Monday, we started by modeling. This was mine. I think this was mine. Nope, this was mine. I showed you my building that I had created, and I really set you loose with grid paper, with scissors. I said, try to make buildings that are going to match these criteria and constraints. Some people ended up cutting out each wall separately to tape together. Some people looked for ways that they could be a little bit more efficient or strategic with the paper and made nets. So a net is the 2-dimensional object that you can fold to make this. Both ways are going to work when you're making your model, and some ways are going to make it easier to see things like the area of the roof, the area that's going to be glassed in, things like that. So I have here 3 models that we're going to use to compare. This is kind of going to guide what we'll be talking about today. This, you notice they all have the same height, but the gardens are very different. So for this one, we have a height of 20, obviously, and a perimeter of 36 units, obviously. But the dimensions are 1, 2, 3, 4, 5, 6, 7, 8 units. And let me write this down in my notes from yesterday. 8 units wide by, let's count the other side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have an 8 by 10 grid. Oh, I don't actually have mine here. Let me write that. And we know that that's going to work if our length is 8 and our width is 10, because if I did 8 plus 10 plus 8 plus 10, I'm going to get those 36 units that I need for the perimeter. So that's this one. This one here has a length of 7 and a width of 11. And if I do 7 plus 11 plus 7 plus 11, I will also get a 36 unit perimeter. So I know it matches that criterion. And then last for our consideration is this guy. So it's 20 units tall, very long, skinny building. Kind of a strange building. You may not see buildings like this too much in actual cities. This one is 17 wide and only 1 long. And we know that 1 plus 17 plus 17 plus 1 is going to give us the perimeter of 36 units. So, all 3 buildings match our criteria, or our constraint of needing to have 36 units. They all also match our constraint of being 20 units tall. We're going to use these to think about area, to think about the glassed area, and to think about volume. So first, I want to know the area of the garden. I could count up all of the boxes inside, but that seems like it could take some time. So there are more efficient ways. In this one, I have 17 in a row, and I only have 1 row. So I could model that as 17 times 1, which is going to give me an area of 17 squares. In the 7 by 11, I have 11 in a row, and I have 17 of those rows, so I would do 11 7 times, which would be the same as 11 times 7, 77 squares. And then for my 8 by 10, it is 10 in a row, and we have 8 rows. So I would do 10 8 times, also known as 10 times 8, which is going to be 80 squares. So a way that I can find the area of my garden is by thinking of those rows and columns, and I end up efficiently multiplying length times width to get that area. Area is not the same for all of these. So if I needed to think about what my client wants, my client probably is interested in more space if possible. So something that people ended up seeing on Monday and making some conjectures about, and we talked about this in each class yesterday, was what makes one garden have such a large area where another garden has a very small area. They have the exact same perimeter, so you're working with the same outside. So why is the inside so different? Something that students noticed was if it is a long, skinny rectangle, it's going to have less area. And if it is more of a square rectangle, it's going to have more area. So it seemed like if you're trying to maximize area, you're going to want to have your garden be more square. So that was kind of the first thing that people were noticing when we were looking just at the area of the garden. Then to look at the area that we're going to glass in, which we also call, and I'll write this out, lateral, which means side, lateral surface area. For that, I needed to look at my 4 walls. So for this one, if I have 4 walls, I know that this wall is going to be the same as the back wall, and this wall is going to be the same as the other side wall. So if I can find the area of each of those walls, I will have my glassed in area. So for this one, I have a 1 by 20 rectangle. So it's just that 1 wide, and it's the whole height of the building, 20 tall. So I could do 1 times 20, which is 20, but we have 2 of them, so I'm going to do times 2. And then for this wall, it's going to be 17 long by, again, 20 high, because that's the height of my building. So I could do 17 times 20, which is which is 340. And we have, again, 2 of those, the front and the back. So that would give me 40 plus 680, which ends up giving me 720 squares. So I would need 720 glass tiles for this 17 by 1 building, my long, skinny building. Looking at my, let's see what we got here. Looking at my 7 by 11, yeah. 2, 3, 4, 5, 6, 7. Yeah, looking at my 7 by 11, my front and my back walls are the same, and my side walls are the same. So for this wall, the front wall, I would have 11 by 20, which is the height, and I have 2 of those, the front and the back wall. 11 times 20 is going to be 220. We've got 2 of those. And then on the side, I have a length of 7 and a height of 20. So I would do 7 times 20, which is going to be 140. And I have 2 of those. So I end up with 440 plus 380, which is, 440 plus 280, which is once again 720 squares. And we ended up with about 10 of these. And students found that every time, no matter how long and skinny that rectangle was, versus being more of a short, fat rectangle, as long as the perimeter was 36, for all of our rectangles here, we ended up with a glassed-in area of 720 squares. And that was interesting, because looking at this building, you might expect that it's going to take a very different amount of glass than this building. But in fact, it takes the exact same amount of glass. So that's what's going on with the surface area here, this glassed-in area. And we want to continue to think about why. If it has the same perimeter, is it going to end up with the same amount of glass? And is that going to hold every time, or was that special just because of the 36? And then the last thing we talked about, efficiency, right? So we want to know about volume. How much space do you have in this building? For that, it's helpful to think about the base. Because if we wanted to stack this and fill it with cubes, how many cubes would it take just for that base layer? And you've actually already figured that out, or we figured that out for these 3 rectangles. For the 1 by 17, it was going to take 17 cubes in that bottom layer. For the 7 by 11, it was going to take 77. And for the 8 by 10, it would take 80. In fact, it's just the area, because that's how many cubes you could lay down on the base. So we have the area, and we have 20 layers of that area. So you would do 20 stacks of cubes. So if I did, let's see, for this one? Yep, for this one, 77, 20 times. Another way that I could write that would be 20 times 77. And that would end up giving me an area of 100, let's see, 77 times, that's the same as 2 times 10 times 77. And 2 times 77 is 154. So we would have 1,540 cubes that could fit there. For our 8 by 10, well, we have 80 squares in the bottom layer, and we have 20 layers, so we can multiply that 20 times as we go up. And that would be the same as doing 1,600 cubes. And for our 17, if we have 17 in the bottom layer and we have 20 layers, that would be the same as having 340 cubes. So unlike the glassed-in area, it looks like this definitely changes. For our long, skinny rectangle, we only have 340 cubes. For our kind of shorter, more square rectangle, we have 1,540 cubes. For our rectangle that's getting even closer to a square, we have 1,600 cubes. So it seems that if the area is larger, you're going to have a larger volume. And that's something else that we started discussing in terms of if you wanted to give your client some options, you might want to have them have more volume. So that's kind of where we are. Starting tomorrow, we're going to be looking at gardens that aren't rectangle shapes, because there are reasons you might want something that's a different shape. Don't have to be a rectangle. And you might find other shapes that are actually going to give you what you want as an architect more than a rectangle would. All right, have a good night. I will see you tomorrow.